Imagine you are a daily trader trying to execute a time-sensitive token swap during a high-volatility market event. At the exact moment you hit submit, the entire system begins to buckle under the weight of thousands of identical requests. Your transaction hangs in a pending state, while the network demand pushes gas fees to thousands of dollars just to participate in the queue. This gridlock is a structural consequence of how current blockchains are designed to process information. It creates a system where users are forced to pay a massive financial penalty simply to access the network during periods of high traffic. The imperative transaction model places the burden of execution entirely on the user. To complete a trade, you are required to manually define the exact routing path, set the slippage, and specify the gas limits. Because every user must broadcast these exact step-by-step instructions to a public mempool, thousands of traders end up competing for the same smart contract simultaneously. This public broadcast creates what is known as an alpha leak. Specialized bots monitor the mempool to read your strategy, allowing them to front-run your trade and extract maximal extractable value. By the time your transaction reaches the contract, the market has shifted, and your trade executes at a worse price or fails entirely. Under the imperative transaction model, the public mempool functions as a surveillance environment that actively penalizes individual traders. Anoma addresses this by shifting the core architectural focus. Instead of providing the blockchain with a list of instructions on how to trade, you simply declare the outcome you want. Look at this comparison. Anoma defines an intent as a simple declarative constraint. You provide a rule. I authorize the sale of 10 asset A only if I receive 20 asset B. This physically separates trade routing from the final on-chain settlement. The separation prevents wasted gas. If your intent-specific conditions cannot be satisfied, the transaction is never initiated on-chain. Moving the execution logic away from the settlement layer transfers the burden of computational complexity from the user to the network. That complexity is managed by solvers. They are a decentralized network of off-chain professional actors who find the most efficient path to fulfill your intent. These solvers compete to find the best possible route and match for your trade, hoping to win the fee for executing your intent. However, if solvers can see the details of your intent, they could theoretically front-run the trade just like a standard MEV bot. Anoma prevents this using zero-knowledge proofs, encrypting the intent before it enters the network. This forces solvers into a blind auction. They submit execution paths without knowing your trade's exact details. Your data is only unsealed at the moment of guaranteed execution. Pre-execution privacy structurally neutralizes NEV, requiring the market to compete fairly for your trade rather than exploiting your data. Let's return to the scenario of a daily trader attempting a complex multi-chain swap during a high-traffic event using Anoma's architecture. The experience is simplified. Instead of managing gas wars, you sign a single private intent and let the system process the request. Behind the scenes, solvers look for a coincidence of wants, matching multiple distinct intents globally rather than relying on a single liquidity pool. This enables a ring trade. If you want Bitcoin and have Ethereum, while others have exact opposite needs, solvers snap these intents together, creating a direct digital barter, bypassing congested middlemen. The multi-party ring trade settles atomically as a single clean record on the blockchain. This entire process of routing and matching occurs instantly and privately. Anoma's intent-centric architecture automates the technical complexities of Web3, prioritizing the user's desired outcome over the underlying execution process.